In this video, we're going to look at the extraction of metals, meaning how we convert metals in their natural forms into the pure metals. So once again, we look at the reactivity series. At the bottom of the reactivity series is gold. So it's the most unreactive metal in the series. So what happens is that if you were to find gold in nature, it will be in its uncombined state. That means it's not combined with any other elements. It is pure gold itself. So there's no need to extract. There's no need for further reaction. It is already pure gold. For all other elements in the periodic table, if you were to find them in nature, alright, it's likely to be combined with other elements such as oxygen, maybe sulfur, chlorine, or even carbon. Okay, so the metals in these compounds, we call them ores. Okay, so this metal combined with the other elements in the compounds, we call them ores. And in order for us to get the pure metal from the ores, we need to subject the ores to some extraction methods. We need to extract the metal out from the compound. Okay, so what do we have to learn now is this: metals below carbon. Okay, metals below carbon, how do we extract them from their ores? Is by heating the ores with carbon. Okay, if you can recall from the last video, in the last video, the oxides of these metals can react with carbon, and on reacting with carbon, we get back the metal. So essentially, we extract the metal from the oxides. How about metals above carbon then? We can no longer, when we heat the oxides with carbon, there's no reaction. So how do we extract these metals? The method is this: it's called electrolysis. Okay, we have not learned that yet, so we'll only learn that later in the later part of the year. So electrolysis of the molten ores. Okay, so at this point in time, don't worry about the term electrolysis. Essentially is to use a current to break down the compound, and on breaking down the compound, we get back the metal. Right, at this point, just need to know for a particular metal what method to use. Is it by heating the ore with carbon or by electrolysis? Now for our syllabus, we're going to look at the extraction of iron in detail. Alright, so it's very important for you to know how we get iron from iron ore. Now the extraction of iron takes place in a very big reactor, and the name of the reactor is called a blast furnace. Okay, a blast furnace. So what do we add into the blast furnace? We add three things. First thing is iron ore. Now iron ore has a special name. It is called hematite. What is hematite? Hematite is actually a mixture of mainly two things. One is iron 3 oxide. The other one is silicon dioxide or sand. This is an impurity. Alright, so the first thing that we add into the blast furnace is that we add hematite. Please note the spelling. The next thing that we add is coke. Coke is essentially carbon. Okay, and the last thing that we add is calcium carbonate or limestone. Alright, and as we add the three ingredients into the blast furnace, we need to flow in hot air, and this hot air is enriched in oxygen. Alright, so we have a lot of oxygen in there. Reason being, oxygen is an important ingredient as well, as you will see later, and the temperatures are around 700 to 800 degrees Celsius. So later on, we will see the reactions that happen in the blast furnace, and we will also see that the temperature will double to as much as 1600 degrees Celsius or 1600 degrees Celsius. So one thing to note is that this blast furnace must be made of a material that can withstand very high heat, and the typical one that we use is magnesium oxide. Okay, so the blast furnace is constructed out of magnesium, or it has some magnesium oxide linings. We call this a refractory material, okay, which essentially means that it has a very high melting point, and then is very good at trapping heat. So at this point, it's very good to revisit as to why magnesium oxide has such a high melting point. Melting point is a physical property, so to explain for it, to understand why, you need to go back to the structure and bonding in magnesium oxide. So now that we have looked at the ingredients that we add to the blast furnace, now we shall look at the reactions that happen. What happens to these ingredients when we add them to the blast furnace? There are four main reactions that happen in the blast furnace. The first reaction is this: your carbon or your coke is going to react with oxygen in the hot air to produce carbon dioxide gas. Alright, this reaction actually releases a lot of heat. Alright, we call it exothermic. We will learn this in energy changes as well. It simply means that it releases a lot of heat. So as mentioned just now, the hot air was only around the temperature of 750 degrees Celsius. Because of this particular reaction, the temperature will rise to around 1006 degrees Celsius. Now the second reaction that will happen is this, is that your carbon dioxide form will react with more carbon, more coke, to form carbon monoxide. Okay, this is the second reaction that will happen. The third reaction is also the most important reaction, is where now the iron 3 oxide in your iron ore will react with your carbon monoxide gas produced in step number 2 to form your iron metal as well as carbon dioxide gas. Okay, to balance the equation, we need to add a 3 over here, 2 and then 3. Okay, now to balance this equation is not straightforward, so I would recommend that you memorize the coefficients, or to memorize the this particular equation, because it's tested very often, and as mentioned, the balancing is not straightforward. Okay, the last thing that I want to point out over here is that the iron metal that's produced, remember the temperatures now reach 1006 degrees Celsius. At this temperature, your iron is no longer a solid, but rather it is molten. Alright, it's molten. Alright, now the last reaction that happened is this. It's actually a combination of two reactions. First, we added limestone. Okay, limestone is going to decompose. Remember, this is a metal carbonate, so when it's subjected to very high temperatures, it will decompose to form calcium oxide and carbon dioxide gas. Okay, and then your calcium oxide now will react with your silicon dioxide. This is the impurity in hematite, and what does it form? It forms your calcium silicate, or which I usually call it a watch brand, Casio. Okay, so calcium silicate has a common name, we call it slag, and at the very high temperature, slag is also in molten form. Now there's one important thing to take note of the very last reaction, which is this. If you can recall, calcium oxide is a metal oxide. Alright, and long time ago, we learned before that metal oxides have a certain character. Metal oxides are essentially basic. Alright, silicon is a non-metal, so silicon dioxide is a non-metal oxide, and we have learned in the same chapter that non-metal oxides are acidic. Alright, so the last equation that we see, the last reaction that we have seen is essentially an acid-base reaction between the acid silicon dioxide and the base calcium oxide. So through these equations we can see the purpose of each ingredient. Carbon or coke is used to produce carbon monoxide, the main reactant that reacts with your iron 3 oxide. And the purpose of calcium carbonate essentially is to remove your sand impurities. So just a quick review: to extract iron from hematite, we need to use a reactor called the blast furnace. We add 3 things to the reactor. We add hematite, we add coke, and we add limestone. And then we need to flow in hot air enriched with oxygen. And after adding everything, a series of reactions will happen, and in the reaction these are some of the products that are formed. You get molten iron, you get molten slag. Now these 2 products will actually sink to the bottom of the blast furnace. Alright, one of them will float on top of the other. So a common question that you will be asked is, which one floats on top of which? And the answer is this: your slag, your molten slag, is actually less dense than your molten iron. Alright, so your slag will be found at the top layer, while your molten iron will be found at the bottom layer. Okay. Now, in addition to molten iron and slag, one of the main products which is unwanted in this reaction is your waste gases. Okay, and one of the main waste gas would be carbon dioxide gas. Okay, the other gas, major composition of your waste gas would be nitrogen gas. Okay, where did we get nitrogen from? Nitrogen is the main component gas in air. Okay, and then we may also get some nitrogen monoxide or nitrogen dioxide. So where did it come from? Under the very high temperatures in the blast furnace, your nitrogen can actually react with oxygen also to form NO or NO2. Now the molten iron that we get in the blast furnace is still not 100% pure iron. In fact, it contains an impurity. So can you all very quickly guess what the impurity is? A hint will be to look at what we add to the blast furnace. So the iron that we get in the blast furnace, in fact we call it cast iron, alright, because it contains an impurity, and the main impurity is actually your carbon. Okay, it contains a lot of carbon. So how do we then purify the cast iron? Is that we need to burn away this carbon by reacting with oxygen and converting it to carbon dioxide. And by burning away the carbon, we convert the cast iron into pure iron.